Okay, this is the P3 paper from June 2024. It's question number 9, which is the last question on the paper. And as we can see, as I scroll down, it's some work on differentiation. We're going to be finding dx by dy, dy by dx, but it also is differentiating trig functions. And then there's a little bit of work on trying to work out the equation of a normal and trying to find an area here. Let's just go through each bit separately though, because first bit starts off okay. So we're given this function, x equals 4 sine squared y minus 1 from y between 0 and pi over 2. And it says this point P here, which is k pi over 3, can we work out what the k is worth? In fact, can we say that it's equal to 2? Yeah, absolutely, we can do that part. So part A, we've got that the function is given by x equals 4 sine squared y minus 1. And then we know that at the points, y, y is equal to pi over 3. So x is going to be 4 sine squared pi over 3 minus 1. Just stick that into the calculator. Sine pi over 3 is root 3 over 2. So root 3 over 2 squared is 3/4. 4 lots of 3/4 minus 1, it works out to be equal to 2. I've only put that extra step in, I guess, because it says to show it. Otherwise, I wouldn't even have bothered with that part of it. But that's part A done, just a 1 marker. Part B then says, can we find dx by dy in terms of y? Yeah, that shouldn't be too tricky. Part B, we've got that x equals 4 sine squared y minus 1. Now, I don't do this, but if you want to have this written as x equals 4 sine y squared minus 1, I wouldn't suggest you do that, but just in terms of differentiating this, if I'm going to differentiate this now, I'm going to multiply by the power and take 1 off the power. So I'm going to get 8 sine y, and then using the chain rule, multiply by the differential of what's in there. And the differential of sine is cos. So we get 8 sine y cos y, and differential of 1 is just 0. So 8 sine y cos y is the answer to part B. So B part 1 rather. B part 2, hence show that dy by dx is equal to this really quite complicated thing here. So, okay, let's go and have a look at what dy by dx is going to be. So sorry, is B part 1. We're now going to do B part 2. So dy by dx, that's okay. Dy by dx, if I've got dx by dy by dx is going to be 1 over 8 sine y cos y. But we want this in terms of x's. So what I've got to do is to get rid of my sine y and get rid of my cos y. Well, sine y is the one that I'll start off with, because we know x equals 4 sine squared y minus 1. So x plus 1 is equal to 4 sine squared y. So x plus 1 over 4 is equal to sine squared y. So sine y is the square root of x plus 1 over 4, which I'd probably actually write as root x plus 1, and then actually do square root of 4 is 2, isn't it? So I've got sine y is written like that. What about cos y? Well, remember, cos squared y plus sine squared y is equal to 1. So cos squared y is 1 minus sine squared y. And we've already got sine squared y a little bit earlier on. So cos squared y is 1 minus x plus 1 over 4. Now let's tidy that up as a fraction first of all. Cos squared y is, the way to do that is to call it that fraction, then do that times that times that, and the bottom 2 times together. I'll let you work that out for yourself, but it works out to be 4 minus x plus 1 all over 4, which is going to be, what's that, 3 minus x all over 4. So that's cos squared y. So cos y is the square root of that. Or in other words, root 3 minus x all over 2. And now both of these two, this one and this one, can be put in there. Let's actually just do that. So we get dy by dx then was equal to 1 over 8, and then I've got root x plus 1 over 2 root 3 minus x all over 2, which works out to be the 8 and the 4 there both just cancel out, so we get 1 over 2 root x plus 1 root 3 minus x. And that's what we were trying to do for B part 2. So we've managed to do all of B now. Part C says the normal to the curve at P cuts the x-axis at point N. Find the exact area of the triangle OPN. Right, so let's actually go back and just stick that on the diagram up here. So what they're saying is the normal at P would look something like, let's just put that in the right place, would look something like that, wouldn't it? The normal is at right angles to the tangent, and they're saying that hits there at point N, and then what they want us to do is to work out the area of this triangle here. So if I want to work out the area of this triangle, let's just stay with this for a second. The area of this triangle, that is quite often in P3 and P4, isn't actually that difficult to do. The area of this triangle is simply going to be the height and the base are those two there. So it's half base times height. So what they're really saying is, do I know the height? Well, I already know the height there, because the height of that length, because this is a coordinate, the height of that length is just pi over 3, isn't it? What about the base then? Right, I need to think about where the normal is going to hit the x-axis. The normal is going to hit the x-axis when y equals 0, but I've just got to backtrack a little bit and say, okay, what they really want, they want me to find the equation of the normal. Once I found the equation of the normal, if I put y equals 0 in, I'll be able to work out what n is, and so I'll then be able to finish off working out the area of this triangle. But we're going to start by working out what the equation of the normal is, and we know how to do that. If we're going to try and find the equation of normal, y minus y1 equals mx minus x1. Let's go and do it. Let's go and actually do this part here. So part C, normal to the curve. If I want the normal to the curve, I need x1, y1, and m. Well, I've got x1 and y1 already. x1 is equal to 2 and y1 is equal to pi over 3. What I don't have is m, which is the gradient of the normal. So coming back here now, I've got the gradient of the tangent. I can work out the gradient of the tangent. Gradient of the tangent, remember, will simply be dy by dx, and dy by dx was, I'm not trying to do it too much on one line, dy by dx was given by this bit up here. So there's dy by dx, and we know that x1 is equal to 2. So I'm going to get equals 1 over 2, that's root 3, and that's, you put root 1 I guess, but that's going to work out to be 1 over 2 root 3. That's the gradient of the tangent I don't want the gradient of the tangent, I want the gradient of the normal. So the gradient of the normal is -1 over that, which will give me -2 root 3. So I've now got, for my equation of a normal, I've got y minus y1 equals mx minus x1. So I'm going to have, as I said previously, in fact, let's bring this down now. I was just explaining it to you guys. Better to have it right there and to have that this is now -2 root 3. So I'm just going to put all that information in. So y minus pi over 3 is equal to m, which is -2 root 3 x minus x1, x minus 2 here. So if I rearrange that, I'm going to get y equals -2 root 3 x plus 4 root 3, and then I can also take the pi over 3 over the other side as well, plus pi over 3 here. So that's the equation of the normal. And now remember, I want to find n. So for n, that was going to be y equals 0. So I'm going to get 0 equals -2 root 3 x plus 4 root 3 plus pi over 3. Let's rearrange that to get x equals. So we're going to say 2 root 3 x equals 4 root 3 plus pi over 3. So x is going to be equal to 4 root 3 plus pi over 3 all over 2 root 3. So let's just tidy that up a little bit. 4 root 3 over 2 root 3 is 2, and pi over 3 over 2 root 3 is pi over 6 root 3. So that'll be good enough to work out my n there. That's my x value. So we wanted the area of that triangle. So the area of that triangle was going to be half base times height. So it was going to be a half this 2 plus pi over 6 root 3 all multiplied by the height, and the height was pi over 3, remember. So that's going to give me a final answer of pi over 3 plus pi squared all over 36 root 3 there. And then let's just check, what does it say about trying to get my answer here? In the form where it's a pi plus b pi squared, where a and b are constants. So I've got it like that. The only thing possibly I might do is to multiply top and bottom by root 3 of this one here, just to get rid of the third off the bottom. So it could be a third pi, and then here if we multiply by root 3 over root 3, we'll get root 3 pi squared all over, and then that's 108. Just have it as the neatest possible answer. Okay, difficult question, a lot of algebra involved obviously, but hopefully that all makes sense to everybody.